Hello, how are you?
Morning.
Right.
Oh, it's interesting times, but I'm okay.
Okay. Good.
You hear me okay?
Yeah, I can hear you. Yeah. Okay, good. So welcome to the meeting. We'll start now, and people, if they come in later, will join in. So welcome to the time change. I don't know. I think the people who were affected by the time change, meaning people outside of North America, are not here. So, but I had to move the meeting back, and well, I kept that at the same time. But if you're outside of North America, that means that you're going to be having to shove it back an hour. So I didn't get any emails from people who said that was a problem, but we'll see. And then I guess they catch up with us in a couple weeks, but it's that time of year. So first of all, I'd like to ask if anyone has any comments or news or questions that they'd like to share.
I mean, I could say a few different things. One of the conferences I was going to go to, which is New York's Celebration of Limiting Computing, that has been postponed, like many other conferences. So that's kind of a bummer, but at the same time, I think I've seen you or other people sharing a bunch of resources on Twitter about how to do things on like virtually.
Yeah,
that's been pretty helpful, and definitely is like something in my life. But outside of that, I'm making some progress on my Frontier Maps project. I'm doing some reorganizing, and I think I'm going to have some different developments of these sections are coming along in the reorganizing. I'm looking forward to adding some more code stuff, especially ahead of I forget which conference is more tailored towards that. That's more the CFB conference. So I haven't worked on anything for that at all, like the presentations yet, but I feel like there will be a lot of good things for me to talk about at that event, so I look forward to that. I think we'll talk about the FPX paper later, but I had some things to bring up for that. And what did I see? Yeah, I think that's mostly it for me. If everybody's staying healthy. I'm in New York, so it's like really starting to spread in New York State here. So, yeah. But I'm okay for now.
Yeah.
Do you have any idea about what's the scenario in Boston?
I haven't heard a lot from Boston, but I know that it is present there, and I mean, I expect it to kind of be spreading, so I'd be careful if you're going there. But yeah, I think New York will be worse at this time.
I think a lot of places it's hard to know because they haven't tested as much as they would or should or at all. So it's, but it's it's one of those things where we're trying to make people are doing all the social distancing stuff to try to keep the virus from spreading fast. So like there's an exponential curve that epidemiologists use to sort of track the progression of the disease, and if you can knock that curve down by social distancing or taking precautions, it actually helps to the timing of the spread of the disease, and it helps in not overwhelming hospitals, and maybe we'll be able to isolate the virus and have some sort of treatment at some point But if it, it spreads pretty fast like that, then it's the probability of that being useful is decreased. And so it's, it's all about that sort of timing and just trying to keep people, because a lot of people will contract it eventually. It's just a matter of managing it. See, I did actually do a blog post on remote.
Yes.
So I don't know if you saw that. I don't have the link up right now, but let me see if I can find it. It's about working virtually. Yeah, I'll get the link here. I'm pulling up the post.
The phrase exponential growth is familiar to
About the video.
You sent a link about this is a great YouTube channel about they show mathematical simulations.
Oh yeah, put it in the chat.
Hi everyone.
Hello, Stefan.
Hello.
Hello.
Oh, do you have any news or what's going on your end of the?
Yeah, I mean, do you want to talk about my OBHM tweet that I've sent?
Yeah,
Or
we'll
should
get
we
to
do
that.
it a little bit later?
Yeah, a little bit later on. I've got, well, the materials are already organized here, so we'll go through what those are. Thanks to everyone for bringing in or sending me their contributions. And I know you guys got the link, or I forwarded you an email about the conference acceptance. So the time is, I think it's 1700 UTC. So that's, I think in my time it's 12 noon. So we'll have to see. I may have to change the time a bit because I have another meeting like close to that. I don't know if I can make the actual time, but we'll see. But right now it's scheduled for 1700 UTC, and then it's just going to be like a series of tweets that go out, and then it'll have a pretty big audience hopefully. Yeah. So I put a link in the chat on this article on that I wrote on. It's on like remote work, and so people have been working remotely for a long time, and now it's just it's becoming in fashion. So I put a bunch of resources in there about people giving tips on working remotely and having conferences remotely, and then at the end there are 2 links to some agent-based simulations. So I see Ankit put a link in the chat as well on that. So if you want to check out those 2 links, they're interesting in light of coronavirus. So anyways, so that's that. And then why don't we go on? I have some papers to review for this week again. I found some interesting things in my reading queue. I'm going to go over them. Let me share my screen. There we go. All right, you can see my screen now. So the first paper is called The Theory of Taxonomy. And this is, it's kind of a complex systems paper. kind of has a mathematical bent to it. Wish this thing would open. All right, here we go. It's going to open up here very slowly. Okay, here we go. So this is it's actually a preprint. It was a while back, so 2016. So it's not really a new paper, but I ran across it this week. So they talk about taxonomies. Taxonomy is a standardized framework to classify and organize items into categories. Hierarchical taxonomies are ubiquitous, ranging from the classification of organisms to the file systems on your computer. And so they want to characterize a typical distribution of items within taxonomic categories. And so they go and they look at ecology and they look at computer science. And it's kind of reminiscent of a lot of the stuff they were doing in early complex network theory and in the power law research that's been done, really early versions of it, where they looked at a bunch of systems and they tried to find principles. So they look at all these different systems and they try to find underlying commonalities. And so they come up with a simple non-parametric branching model, which is basically a tree. It randomly characterizes items and takes as input only the total number of items and the total number of categories, successfully reproduces abundance distributions in these data sets. So they're able to look at the variation of these classifications, and they find that they're similar. So, classifications are human constructs. We classify things in a certain way. We use things that are sort of maybe natural, like in species, we use features like different morphological features or maybe DNA sequences. But those are things that occur in nature. They're features. If you want to talk in terms of machine learning, it's a feature space, and we try to create categories out of that. And so they're saying that there's some commonalities amongst different category systems. And so in this case, they're talking about hierarchical taxonomies, and which are where you have categories that incorporate other categories. And so they looked at the distribution of items across different systems. And so they use this thing called the species abundance distribution, which is a tool borrowed from ecology, which is it's sort of based on information theory, but it's a way to look at different, different like species or different classes of something, and then look at the relative abundance in a system and come up with a parameter. And so they actually it's a distribution, and they come up with this. They use this equation to come up with it. So this is the representation of a binary hierarchical tree, which is what a lot of classifications are if you abstract them away to a data structure. And then they look at the distribution of these different binary classifications. And then they have a comparison here for different types of systems. And so they have numbers of items and numbers of categories in blue, numbers of items in green. And so it's quite variable across different types of systems. But you always see that the number of items exceeds the number of categories, and that there are different, there's a lot of variation, but there are probably some commonalities as well. And then here are the distributions. Histograms of this distribution. So you can see that some systems, like the Harvard Library and the microbiome, have certain signatures. You have distributions like, I guess this is the Amazon, maybe species abundance in the Amazon. This is a hospital. This is archive. And so you can see the idea would be to find common distributions that are very similar across seemingly dissimilar systems. And so Let me see if there is anything else here that's interesting. I think that's pretty much the gist of this paper. So they actually have their data sets listed here underneath the paper body itself. So they have, actually, these are all open data sets. So these are things that people can analyze on their own. And so it's a real abundance, a real variety of different data sets. So that's that paper. And you might find it interesting if you're into machine learning or something, where you do a lot of classification. Okay, if Jesse says, if I randomly leave the MPG for 5-10 minutes, it'll be for an important phone call. I'm not sure when it'll arrive, but I will be back. Okay, why don't I go through these papers and then we'll see. I wanted to maybe I'll do the where's the launch? Maybe I'll do the OHBM stuff while you're gone, and then we'll see. Okay.
Yeah, I mean, you don't have to change any of what you're doing. It's just if I drop out randomly, I'll be back, so don't worry about it.
Okay, well, I just wanted to talk about the essay when you were here, make sure that we didn't.
Thank you.
Hi, Devanch, how are you?
I'm good. How are you, sir?
Oh, good, yes. So, the next paper is The Rise and Fall of Symbolic AI, and this is a blog post from Towards Data Science. And this one is a
Nice.
yeah, so this covers sort of the history of early AI and something they call symbolic AI. This is a picture of Alan Newell and Herbert Simon. So these were two big names in early AI. They did a lot of what they called expert systems and other types of rule-based systems that everyone thought at the time was like the key to understanding intelligence or making intelligent systems, and didn't work out that way as we know now. But this basically talks about that history. So work in AI started with projects like the General Problem Solver and other rule-based reasoning systems. This became the foundation of AI for about 40 years. It's from the late 40s to the 80s, and then this is when you started to have neural networks come up. Perceptron was about 10 years earlier, but this was like the dominant mode of research for quite a while in AI. And so if such an approach is to be successful in producing human-like intelligence, that is necessary to translate often implicit or procedural knowledge possessed by humans into an explicit form using symbols and rules for their manipulation. So what they were trying to do is take so procedural knowledge is where if I tell you a set of instructions on how to do something, if you can reproduce those instructions without my prompts, that's considered procedural knowledge. So it's the basis of learning, because there are many types of learning, but that's one important type of learning. If you want, say, an intelligent agent to do something, you think, well, you would mimic the procedure that a human would use. And so you have to teach that procedure, and of course, you would use symbols to do that. The problem, of course, is that that's not the only type of learning, and B, it's actually quite hard to do that. And it's easy to do just a set of instructions for artificial intelligence to sort of reproduce those, but to come up with new solutions to a problem is actually quite hard. And so that's kind of the problem that they had with this kind of method. So they talk about AI and philosophy. Alan Turing asked in 1950, can machines think? If yes, then are we machines? And so this gets into the philosophy of mind a little bit, and sort of how people were thinking about this AI problem in the context of philosophy of mind. And it leads into this idea about using symbols. So, symbols are we can define them very broadly. It could be an alphabet symbol, like a letter. It could be a number. It could be something in a road sign, like the word stop. If you see a stop sign, it's an international convention of what that looks like, so that people know what to do when they see that symbol. where you could have things, objects in the world that are symbols of other concepts, like an apple may be something that's edible, or it could mean a teacher for historical reasons, but we know what that connection is, and we know what that symbol is. And so, I mean, these are things that are, sometimes they're culturally specific, sometimes they're universal, only because we've made them universal. But it's definitely something that people thought that if you teach computers how to think that way or use symbols, then we can kind of get it to the heart of intelligence. Again, it didn't work out that way so much. So there's a lot of stuff in here about dualism, philosophy, thinking machines. Then the fall of symbolic AI, which is where basically it ran up against itself. There are a lot of problems with implementing a symbolic AI. In theory, it looks good, but there are some unresolvable issues. So one difficult problem that came up was that you had this common sense knowledge problem. So if you give intelligent agent a set of instructions, it can, replicate those instructions. But if those instructions run counter to common sense, then the intelligent agent has no idea what to do. So, you might tell it to do something like bake a cake, and it has all the ingredients, and it can bake the cake successfully. But if there's an ingredient missing, then, a human chef or a human cake maker would decide to to sort of improvise and find something that's similar as an ingredient and use that. An AI could not do that because they don't know. Only thing they know is that procedure. And if one part of that procedure fails, then the whole thing fails. And so the idea would be if you had a truly intelligent agent, they could get around those sorts of blockades in the procedure and improvise. But the problem is, of course, with a symbolic system, you really can't do that because you would have to have symbols for the thing that's being improvised, and that's something they call creativity. And there are people who are working on creativity in AI currently, and they've made some pretty interesting advances, but I don't know if it could solve the problem that the symbolic AI people ran into. It's more along the lines of like how can computers be creative, but it's outside of this paradigm. So let's see. What other kinds of things that they run into? So I mean, basically, this symbolic AI approach runs counter to the neural network architecture. So neural network architectures are sort of the thing that took over afterwards. And neural network architectures are sort of implicitly non-symbolic. So it's a connectionist view. So you have a bunch of connections and you see which ones are the most supported by your data or, whatever you're doing. And there are no symbols involved. I mean, you could probably create a hybrid system, but the idea is that it's counter to the system or to the symbolic approach. So they created things like programs that would play checkers, and the idea was that they would do this procedure of playing checkers, and the computer could learn those procedures, but couldn't improvise moves. It would have to, it would basically create look ahead in the board, see all the possible outcomes, play certain moves, and then wouldn't be able to work outside of that too much. So I mean, they didn't really work out. I mean, they were able to play like checkers and chess decently, but the real sort of things that defeated humans in these domains were not symbolic systems. They were later connectionist systems. So I'm thinking of like when Garry Kasparov got beaten by Deep Blue. That was a connectionist system. That wasn't a symbolic system. And so that's an interesting article if you're interested in the history of this stuff. And then the third paper is Forms of Prediction in the Nervous System. So this is more of a neuroscience paper. And the idea of this paper is that the nervous system is some people call it a prediction machine. And so This paper is a review of a lot of the ways in which the nervous system predicts things in the environment. So there's a widespread tendency to conceptualize the influence of predictions exclusively in terms of top-down processes, whereby predictions generated in higher level areas exert their influence on lower level areas within an information processing hierarchy. So then this excludes from consideration the predictive information embedded in the bottom-up stream of information processing. So they kind of go through how the brain processes information. It's either top-down, which is imposing order on the stimuli, or bottom-up, which is where the stimuli sort of form their own representation. And so there are different approaches. I mean, those are the two different ways that people think the brain sort of imposes order upon the stimuli coming in. But, we have to consider that when we consider how the brain actually predicts things, like your next chess move, or maybe what's supposed to be in a scene. Like, is it, we oftentimes infer things in visual scenes that are maybe not even there, but we have a prediction mechanism in our brain that does this. And so they go through a lot of the sort of the standard models that have been around. They actually mention the law of requisite variety in here. So they actually, W.R. Ashby formulated the law of requisite variety and the good regulator theorem, two complementary principles that are germane to our considerations. These principles offer useful perspective on the nature of prediction. They imply that considering the structure of relevant environmental influences has the potential to provide important and principled insights into the design features of agents or of the brain that is doing the predicting. So they actually have a box on learning from cybernetics as well. So this is a kind of a sort of a recap of how the brain as a prediction engine fits into cybernetic theory. So they talk about good regulators and variety. So that might be worth checking out, especially for Jesse, but everyone else.
Yeah, that's cool.
Then you can implement a possible neural network of predictive coding. So they get in. So this is very computational, which is why I bring it up. It actually gives a lot of ideas for how to represent something they call predictive coding into an agent. And so in this case, you have a small neural network that's producing some sort of prediction. And of course, this can be scaled up to a larger neural network as well. So I'm going to move on to our other stuff, but I'm going to put a link to the folder in the chat so that everyone can get access to the papers. And if you don't have access to this, send me a message, although I think I made the permission so that everyone should be able to access them.
Yeah, I guess.
So any questions about those papers?
Yes. Well, sorry, I didn't know my mic was on. But it is. I was just going to say, I don't have any questions, but definitely interesting. So I will probably have questions afterwards.
Okay. Yeah, that's good. So that was the papers, and just feel free to let me know if you find anything inspiring from those. We can discuss those later. The next thing I want to get to. Oh, Ankit?
Yeah, I had something to say. I just came up with something. So
Okay.
you talked about the brain and creativity in an AI. So there's something called concept formation. Concept formation that we as human beings do, but some AI system or some robot is always feeded with the stuff, so they work in some way. But I was going through a TED talk in which he showed that if they represent a thing, some kind of like a circle and a stick, together, and if it is a small circle and a stick and a big circle and a stick, so these things together, if you call them like a family, and I think it will be hard to say by words, so I would send a link later on, and we can discuss on that later.
Okay. Yeah, that would be good. Yeah, there's a lot of stuff on like on categorization and concept formation and creativity. That's an area that's sort of interesting to read through, and definitely it's an open frontier in AI research, because people have been trying for a long time to kind of figure out how to make, how to connect that with like something that can be learned by an agent. So those are things that are they're open areas. So we can talk about that in future meetings, definitely. So next thing I wanted to get to is the OHBM X conference. So, like I said, I sent the email that said we're presenting on Friday during the conference, and the time is still, it should be 1700 UTC, but it might be changed because there might be a potential conflict there. But we have the materials here, which is the important thing. So I came up with some draft tweets based on the paper and everything else. Let me open up this document. And so the idea is to have 6 tweets, 240 characters each. That's the upper bound on the character limit. And so this is coming up twice. Let me just do it here. So this is coming up on its own. Okay, it's going to come up as a document. So here are the 6 tweets. So tweet 1 would be neuroethology is a study of brain and behavior in the context of an animal's natural environment. This can be specified and controlled in simulated environments through interdependencies among brain, body, and the environment. So that's the introduction, sort of the introductory tweet. Then there's no image specified with this. Then the next one is, we use developmental Bratenberg vehicles, DBVs, in tandem with naturalistic digital environments to study behavioral development. The variety of approaches presented teaches much about the variety of developmental experience. And then maybe not use variety twice in this. Maybe range or range of approaches. Just the approaches presented, maybe. I don't know. But this is basically the second tweet, and there's no image associated with this either. Then we get into the instantiation. So the third one is, one approach to DBVs involves using genetic algorithms to produce a pattern of nervous system connectivity. The fitness function is based on triangulating prior movement vectors and results in sensory motor driven spatial learning. So this is the one from Stefan, and this is I can't remember what I'm calling it, but figure 3, which is if you look at the folder, it corresponds to an image that I have in there. So then that would be an image that would be associated with that tweet. And then that would be so then the next one is, a second approach is to use a multisensory, olfaction, gustatory, or olfactory maybe. And this is Z's platform model of the environment. Individual DBVs explore such environments while their brains use heavy and learning to encode information and develop nervous system connectivity. And so this is Z's figure, and we'll go over these figures in a little bit. And this would be attached to this one. Then tweet number 5 is a third approach to DBVs or BV collectives, and we have the definition of BV and DBV up here. A homogeneous population of vehicles respond to a common stimulus, which produces large-scale response patterns. These patterns can be understood as extended neural phenotypes. And then, without getting into anything about like deep learning, which is, of course, in the paper, but we don't talk about it directly. So then that's a figure that I will create for Enkit stuff. And then the last tweet is, interested in learning more? Then check out our preprint live now on ResearchGate. There you will learn about our open source software packages and in general more about, in general more about DBVs. And this is the link. And then there's another figure here at the end, which is the last figure, and that would be attached to that one. Actually, this should be generally, maybe. So then all these tweets are within 240 characters. So it's, it's just basically, this would be posted first, then we'd wait about maybe 80 seconds for the next one, then 80 seconds for the next one, and so forth. And then that should span about maybe 13 and a half minutes, 14 minutes. And then at the end, I guess you give some time for people to respond with questions. But it's, it's like, usually they don't do that. They just kind of comment offline. But that would be the plan for that. It would just be like 1, 2, 3, 4, 5, 6. And then the images would be attached to those tweets. So I don't know if people think those are good. If they want to, I know Stefan sent me some description and I included that in the tweet. And I tried to be like, faithful to the paper. So then, at the end of the presentation, we send them to the paper. And then we have these images. So the images are actually, let me see. I don't know if I have this shared with people, but I'll send you this directory here. This is the.
Yeah, I was going to say I didn't have it.
So this is the directory for all these files. So in this directory, and if you can't get access, I'll send you permissions. But we have the tweets, this document here. Then we have the graphics, and then this is the presentation. So this is graphic 3, graphic 4, graphic 6. So this corresponds to the figures that I have in the tweet deck there. So graphic 3 is the one that was sent to me by Stefan, and this is Stefan's figure. This is for Broadgen Brain. And so this is very nice that he has the genetic algorithms in color. And then he points to the screenshot. This is the world object. This is the vehicle here in this box. So we have a diagram of the vehicles. We have an output movement vector. We have a signal from sensor. So all of that is defined. And then it's all mapped to the interface. I think the screenshot is fine. I don't know if it's a bit hard to see. Maybe I'll play with the background shading on the image, but it should be fine. Because you see the vehicles here. They're kind of this color here. I can change the color on it though too. It's not a big deal.
All right. Yeah. I mean, I can also try to change the colors programmatically somehow. Just to run the simulation once again and maybe change the code a little bit so that we have different color of vehicles.
Yeah, that might be good.
That might be good. All right.
We might just need some deep colors there.
Well, I mean, for the figure, yeah, we can change the color, but I think he was talking about in general in the simulation. But which would be good because it does come out like, it has the gray background and then it's like a beige color I mean, it's not I mean, you can see it if it's like, full screen size, much easier, but just in terms of the figure, I can change the color pretty easily.
Also, the thing that I could do is just to point, we see the frame that I kind of zoom into, right?
Yeah.
So square with one world object and two vehicles, basically. That's why I picked exactly this square. I could just paint these two particular vehicles in red so that we kind of know what we are talking about here. Maybe that would be also the way. What you think?
Yeah, we could do that. So it would be, to have that would work.
Yeah, and we'll also kind of distinguish the vehicles that we are showing and zooming in from all of the other vehicles that are running in the world. Maybe that would be also kind of, exactifying.
Yeah, that
I
would
don't
be
know.
good.
Just
Yeah.
all right. I can do this. I would suggest the red color for them.
All right.
For these two.
Yeah, red would be good. Just to have the maximum amount of contrast from the background. Yeah.
Sure. All right, I'll do that.
Okay, thank you. Any other comments on the image?
Yeah, I was just thinking about maybe, what you guys think about the fonts that I've picked, about the size, or maybe I should do something. I can also do them bold or italic. That would be also an option.
I mean, I think it's fine.
Okay.
Anyone else?
If anything, in the current setup, maybe just make the broadgen brain interface title a little bit bigger, and maybe even put it like in the off to the right a little bit more, just so it has more space.
Oh yeah, in this blank space. Yeah.
I was thinking about the same thing. There's a lot of space, so maybe the fonts can be increased a little bit more. Because if someone is doing that on cell phone or something like that, it might be hard to read stuff.
Okay.
Just because there is no space.
Yeah, I can move the title a little bit upwards, and I can also, I could do, just so that all of these three parts have a little bit bigger distance between them. That would be also an option. You think that makes sense?
Yeah.
And you can also label A and B as repositories in the chapters in their left button column.
Okay, so all the objects that we have, that I just label all these black dots with A and B according to whether this object is a repulsor or an attractor.
Yeah.
Yeah, that would be a little bit difficult because I even don't remember this myself. That would be probably something for the features that we could build in the simulation itself.
No, I see.
Yeah, so right now it's a little bit.
Yeah, I think we don't need to put too much information in it, but
Okay.
just because we're just trying to whet their appetite, they can then read the paper for sort of more. But yeah.
Okay. Yeah, that's one thing that I was thinking maybe about doing is numbering all of the three parts. So just putting 1, 2, 3 on all of those. But on the other hand, I mean, I then try to depict all of these parts as parts of the same process. So, this kind of circle logic of this, that we kind of take these two vehicles, look at their brain networks, then we mutate the brain networks, and then this last arrow that is pointing back to the simulation is kind of stating that this way we put new modified vehicles back in the game and do the whole thing once again.
Yeah.
I think the genetic algorithm part is actually really good.
Yeah, that's thanks to Google. It was a good picture that I found.
No, I think it's fine. I didn't want to get too, because, if we number them, then you have to define the numbers. I think this is good. Maybe add in a couple of the things that you mentioned, colors, and then just highlighting a little bit more on the vehicles. But don't go overboard with, like, numbering subsets. And I think people can get a decent idea of what's going on here, and that's what we want. So.
Oh yeah. Yeah. All right. I'll do that.
Okay.
Yeah. It's also just a matter of not overloading the picture with too much information.
Yeah.
Yeah.
So then graphic 4, which is from Z, this is his graphic. And he has a different way of doing it. He gives the environment bounded by this dashed line, and then he has the inputs odor and taste, and then the Brainbird vehicle is this box with association being this sort of feedback, but it's not really a feedback. And then the change in movement to avoid the unpleasant is down here. So this actually lists all the things in the Brainbird vehicle that are going on. So I think this is a good way of doing it too. And again, people are just downloading these and looking at them later. They're not like, trying. I mean, maybe they'll try to read it in like 80 seconds, but I think that they'll probably be able to download it and look at it a little bit more. So I think this is a good, clean way of doing it. So yeah, I think this is. Do you have any comments on this one, anyone?
It looks good.
I might make the Brainbird vehicle box itself a different color or shade, just to differentiate it a little bit more, so people who don't know much about it would understand, like, oh, this is a very different thing from like the environment or just the white background.
Yeah.
But it's just aesthetics.
Like a light gray. I mean, nothing like too dark, just so that you can see. Yeah.
I think I should also, like Stefan, just like include some samples of as well as the environments, so all people know what the environment is like.
Yeah, that would work.
I would maybe also suggest, make it a little bit more lively. Maybe you could put some icons, for instance, for order or taste. Something that you find on this website with a lot of SVG icons. Maybe some symbol for order or taste. Difficult, but maybe one can find something there. Because this way it probably would capture the attention of the attendant more. Just seeing some icons that symbolize something.
Yeah, and kind of like playing upon it even more, like if you had like almost like an emoji, like odor or taste, and then maybe like a rat, and then like the odor or taste on the left, the animal in the middle as the vehicle, and then you could have like the rat emoji or whatever going one direction and then another direction, like at the end, sort of like representing it with just like very simple pictures underneath them. Maybe might help. But that'd be more involved. But it's putting extending what Stefan said.
All right. Yeah. So that's Z's figure. Then this one I haven't finished Ankit's figure, but I'm going to, sometime early this week. And this I'll have to like just send him, like how I'm gonna put it together and send it to him, and we'll discuss it on Slack. But this is, of course, these are Ankit slides that he sent me, and those of you who were here last week saw this, where we have a bunch of images of the different vehicles. So, we have all these different vehicle types that are modeled. And we have these different patterns, and we actually have the animated GIFs. But I'm not sure that the animated GIFs, I might just do like a static version of it. So like putting in like an image, a bunch of images with like where it's in this sort of state where there's some collective response to the stimuli. So, in ways that make it look different. So like 2A might be like a static shot of this. 2B might be a static shot of this. Just to show the attraction and repulsion properties of the collective relative to the stimulus. This would be a nice one to take a shot of. And we have the, I don't know if I can fit a link in, but we have, of course, the repository for all the animations. So that's, maybe just put that on the figure, like say, for animation C, and then have like a link, like in a text box somewhere on the figure. That way they can go to the figure. And then, so I mean, this would be a lot bigger, like in terms of size, but I don't know I don't think there's a limit to, well, I think there is a limit to image size, but I don't fit it with this. So we'll just try to do that. And then the last figure is this one's graphic 6, which is the final tweet. And this is a shot of the readership stats. And then a little preprints explainer here for people in case they are skeptical about preprints. But this is the sort of the stub for the ResearchGate submission. So we have the DOI, we have the authors here. Well, Jesse doesn't show up immediately, but you can click this. And then we have the research interest number, 44 reads, and it's been up maybe about a week. And then one recommendation. So, people will be interested in that. They'll say, oh, that's people are interested in it. So it'll be a nice recap to the rest of the talk, and, they'll be able to go to the link in the tweet for more information. And so, again, this is happening on Friday, so if you can join us at the time, and if there's a time change, I'll let you know, but right now it's scheduled for 1700 UTC, which is, I think in the US it's around noon, or 1 o'clock in the afternoon, and in India it might be, I don't know.
It's 10:30.
10:30? Okay.
10:30.
Yeah. So, I mean, people are doing this around the world, so the whole thing is like a 24-hour series of sessions. So, and then
I think it's a good time. It's like afternoon in the US and like evening in UK, and it's like just before midnight in India. So
yeah,
it sounds good.
All right. Okay, so then last thing we need to talk about today is the essay for FQXI, and so this is something that originally was due in 2 days, but we have a slight extension on it because of coronavirus. They wanted to give people time to, finish up. So I think they added a week onto it. But I'd like to submit this.
Before that, about the archive preprint, what's the status of that? Did you get anything from that?
It's still on hold. I don't know what they were waiting for, but I don't know. I'll just leave it in there, and then if they put it out, then we'll just we'll have that. But I don't know what they won't tell me. They won't give me any more updates on it. So I don't know. So this is the essay, and I'd like to get this submitted as soon as possible. I know that they've extended the deadline, but I mean that's just I think good for in case you get coronavirus or something. I don't know, but this is this is the state of this essay. Let's see, got a comment here.
Oh, sorry, that was unrelated comment.
Okay.
Yeah, it's kind of.
Well, yeah, actually, if you have Jesse, if you have a contribution you want to make in terms of a graphic, feel free to propose something. The first and second tweets don't have a graphic associated, so those might be good to have like something.
Yeah. Yeah.
Okay. So this is the current title, and this is again linked to some things in the conclusion of the paper. So I'd like to keep that kind of the way it is. And then we have the quote and the introduction. And so I think we've been at work here kind of fleshing out everything, and I think it's been pretty good. It looks pretty good last time I read through it. So this is a comment from Jesse. Okay, so he's adding in something here.
I added that paragraph and a little bit of time at the end, and it's completely open for review because it's adding a little bit of framing to it, but it may not fit. So that's open for discussion. But
Okay.
my recent edits were basically that, and I still have to go over. There's a paragraph I highlighted that was mostly, I think, something that I instigated below, like in the next section. And I still want to rework that paragraph, so it's not quite done yet. I don't really like it, but it's like my doing, so I'll adjust that later today.
Okay.
But those are like the updates that may have changed since you last saw it.
Okay. And then, so this paragraph, is this new, or is this like, I can't remember.
Yes.
Okay. So
I believe that's entirely new.
Okay. And then, so I'll read through it later, but
Yeah.
All right.
Don't worry about it.
Yeah. So we have the difficult to quantify section. And then this comment, Roman's complementary approach are e-verifiers. So what does that refer to?
It's someone else's submission to the same concept that they already put out, and I don't think it's something that we can necessarily, I'm not trying to like copy their essay or anything like that, but it was interesting in the light of basically Roman Polsky. He's very big into like he's into cybersecurity and computer security in general, and a computer scientist, but he's also very interested in like AI safety and various versions of that too. So this essay was mostly about using the problem of verifiers to confirm a truth, something that an artificial agent might create. So his paper was looking at how agents can verify supposed truths, and I'm trying to look at this here to see. It could put. I don't think we're going to really add it to this paper, so I won't go into it much more. But I would say it's sort of a potentially complementary notion to what you were getting at there about creating this new field, and then ways of confirming what those the paper seems like front of it. A way of sort of confirming what you were getting at, or complementing that approach.
Okay.
But yeah, we don't have to go into it because I don't think.
Okay. Well, we might add in a little like comment on it, like verification or something. That like I like the idea, so I just wanted to make sure I understood what that was, and maybe I'll add something in here. Let's see.
I can show you the Romans paper if you particularly care, but it's also kind of I won't be disappointed if it's not integrated in the paper at all. So.
Yeah. I'll just put a note for myself there. Well, I'll think about that too. And then difficult to symbolize and represent. We have that. And so this is the rest of this paragraph needs some work. So this was from March 10th.
Yeah.
And in the interim, I kind of reorganized this. I don't know if you've read this section here, but I please, read over it, make sure it makes sense. Because I reorganized it, but I still don't know if it makes sense to other people. So, just to do that. And so we have a lot of different themes in here. Wicked problems and symbolization and Newell and Simon's physical system symbol system hypothesis, which was something that they didn't talk about explicitly in that blog post I shared, but that's coming from that school of thought. So it's this is the thing with these essays. You get a lot of ideas that bubble up to the top, but you can only mention them in passing sometimes. But I think there are a lot of good ideas floating here. Okay, let me have this idea of physical analogs. Can this be made more clear? Yes. I'll have to think about how, but it'll probably take maybe a sentence or two. Actually, I can probably add in like a that's just for me. So there probably is something that can be done there. Diatom biomechanics, which I bring up. There was a talk by one of our colleagues a couple weeks ago on the different models that they've used to characterize diatom biomechanics. And historically, and this is about over 250 years, they've come up with 20 different metaphors for the movement. And diatoms are these little marine microorganisms that are microscopic. They move around in colonies, and people have been trying to describe that motion, what's producing it, what's driving it, etc. And they've come up with about 20 different metaphors. And so some are more plausible than others, and I mentioned that in the essay, but it's definitely an interesting topic. So
I thought that was a difficult reference.
Yeah. The open questions to address. We have the 3 open questions. And please read through these to make sure they make sense. That I think the thing I'm thinking of is like complete sentences, because I don't know if they're all complete sentences or not. I'll go through them too, but I just want to make sure that they read like coherent things. Sometimes you write things and especially in these bullet points, and they're not complete sentences, so you have to kind of pay special attention to that. So then, is a new paradigm for measurement and computation the answer? So we've made a couple of corrections here. Okay, can we go over this in the meeting briefly? I wonder if this is what I attempted to work towards in my effective computing research. So the thing
we can not do that right now since we're later in time, but maybe like next time we're in Slack. That's more of a note for myself.
Okay, yeah. So yeah, we'll follow up on this. And then, so we have all these different potential methods, and I think what I need to do here too, and I didn't notice this before. So I mentioned perceptual statistics up there, but I don't really link it to this very well. That's something that is sort of like a loose end, as they call it. So you get you mention something and then you mention other things and you don't make the link. So that's yet to be done. I'll just have to think about how to make that link better. And then so then we have our 4 points here, and then the conclusion. So Jesse has moved the sentence here. It's probably good to do that.
The conclusion was the editing looks kind of funny, but it's just me adding a sentence that's related to what I added above. Essentially, what I added above was attempting to put a wrapper around I'm not changing anything, but I attempted to put a wrapper of all of these solutions that we're having are ways to help create more differentiation between being able to provide more information in situations that are very hard to create differentiation from to begin with. So that's kind of what I mentioned in the Wiener Code about information, and I just tied in there with that. So again, we can go back and see if that wrapper fits or is too much of a stretch or not. But there wasn't any substantial changes to the pre-existing conclusion text outside of that.
Okay. All right, that sounds good. So yeah, I'll look it over, and please look it over. This will get submitted maybe early this week. So I mean, if you have any comments, probably do it this weekend. And then it'll be submitted, and then we'll have a copy on ResearchGate. We'll have copies submitted to FQXI, and when it goes live, I'll send a link. And then what'll happen is people will comment on them. Hopefully we get some good comments. Sometimes you do. Sometimes they're just kind of wacky out there comments. And I mean that with all respect for the people making them. Like, they're not sometimes they're really interesting, but sometimes they're just like people just say something and it makes no sense. I don't know why that is, but it just sometimes it does. Sometimes it may be spam or something, but so these are the references. Okay, we'll add in the Viner reference. Well, the numbering is fine. We'll figure that out. But okay, this reference, yes. And actually, I have this book in my library, so I know what it is. So this is 4. Add that in. Okay. All right. So thanks for meeting today. Any other questions before we go?
That's it. I asked for the request permission for the Google Drive for the folder for the other conference topic, but that's about it for me. Thank you.
Z, do you have anything? Okay. Stefan, Inkit?
It's fine on me.
I have something to say. I would say on Slack.
Oh, you'll say it. Okay. Yeah, send a message on Slack. So the Twitter conference is next Friday, and we'll be, then the next meeting we'll kind of recap that and see how that went, and then the same with the essay, which will be submitted sometime this week, and we'll hopefully get some feedback by then. And otherwise, if you have any other things if you want to update your figures, you can do so before Friday. Just send me a new version of it, and I'll put it in the queue where I'm assembling everything. So thanks for attending this week, and have a good week.
Bye.
Bye.
Take care.
Have a good week, everyone.
Okay, take care.
Bye-bye.